We've been talking about the layers of skin. They're part of our integumentary system. The outer layer, remember, is called the epidermis. Actually, here's a better slide. The outer layer's called the epidermis. And then underneath the epidermis is the dermis, remember? And then underneath the dermis is the hypodermis, or the subcutaneous tissue. Now, the epidermis is made of two major layers that we're going to remember. The outer layer. Does anybody remember what the outer layer of the epidermis is called? The part that's keratinized, made of dead cells. It's constantly falling off because other cells are pushing it from the bottom. It's one of those stratums. It's not the hair, Daphne. Talking about the outer layer of the epidermis. We're doing a little review. So, right here. What's the outer layer of the epidermis? All right, here. All right, here. Guys, you're getting close. You're throwing out some things that we've talked about. So the I'm not sure. Are you saying papillary layer, Jose Manzo? Dermal papilla. Okay. So that would actually be underneath. These are the dermal papilla here. That's part of the dermis. I'm talking about the epidermis up here. The footprint is a result of the dermal papillae and all of those layers on the epidermis. I'll give you a hint. It starts stratum. Oh, Daphne, good. The stratum corneum. Exactly. So the outer layer is the stratum corneum. And then the lower layer of the epidermis, what do we call that? The lower layer can be found right there. The lower layer can be found there. Can also be found there. Can be found there. What do we call that layer of the epidermis? It also starts with the term stratum. We're still in the epidermis, guys. We haven't got to the hypodermis yet. So the stratum corneum is the outer layer. What is the lowest layer of the epidermis? So, Fernando, you're thinking lowest layer of the skin here. That would be correct. Daphne says the stratum germinativum. Yes. So the lower layer is the stratum germinativum. So that's what these arrows are pointing to right here. That is the epidermis. Outer layer is the stratum corneum. The lower layer is the stratum germinativum. Now, underneath the epidermis is the dermis. And the dermis is made of two layers. The top layer of the dermis, what do we call the top layer of the dermis? Daphne says the papillary layer. Anybody else want to jump in? So Jose Manzo, the adipose tissue is at the very bottom here. So that would be part of the hypodermis or subcutaneous layer. Up here, let me draw a little line. This top layer of the dermis, top layer of the dermis is just what Daphne said. It's called the papillary layer. Good job, Daphne. papillary layer. That's the top part of the dermis. Now, what's the lower layer of dermis called? What's underneath the papillary layer? So it would be down here, down here, down here, down here, down here. Daphne's asking reticular layer. Anybody want to answer? If the top layer of the dermis is the reticular, I'm sorry, the papillary layer. Darn it, you're right, Daphne. Yes, reticular layer. So the lower layer of the dermis is the reticular layer. So we have stratum corneum. That's part of the epidermis. The very bottom layer of the epidermis is the stratum germinativum. This is where all the cell mitosis takes place, so all new cells are being made for the skin. Underneath the epidermis, you have the dermis. The top layer of the dermis is the papillary layer. It's about from here to here. Then all this stuff underneath is known as the reticular layer. And then the very bottom layer of this skin is known as what? Epidermis is on top, dermis is in the middle. What's on the bottom? Yari says the subcutaneous layer. Jose Manzo says the hypodermis. Both of you guys are correct. You can go either way. You can say hypodermis or you could say subcutaneous layer. And it's basically just adipose tissue with some loose connective tissue. So we don't break that lower layer up into anything else. All right, so inside the dermis, there are all of these structures. We have hair, we have these erector pili muscles, we have blood vessels, we have sebaceous glands, we have sweat glands, we have pain receptors, we have touch receptors, we have heat receptors. These are all known as the accessory structures. We're going to learn about each one of these accessory structures found in the dermis. The first one we're going to learn about is hair. So I want to ask you guys a question before we start taking notes. And the question is, why do you think we have hair? Why do you think we evolved to have hair? What benefit does hair give us? Okay, so Daphne says it protects the brain from the heat. Okay. Jose Manzo, please use English. Yare says to not be cold, so to keep us warm. What else do we got? Why hair, guys? There's a lot of people out there not participating. I need you guys participating. You are getting a participation grade too, just so you know. That'll be calculated at the end. It looks nice, Jandy said. Or to look nice. That's definitely a benefit, right? To be different from each other, to distinct each other. Okay, Yare, good thinking. Jose Manzo says that to get a good style. So maybe there's some type of benefit to how you make it look. Any other thoughts? What are the benefits of hair? Why do you think we have it? Louis says to protect us from the sun. Ooh, interesting. That sun if we're outside a lot, it's going to be beating down on the top of our head, right? A lot of harmful ultraviolet radiation constantly hitting our skin can damage the dermis, right? It can cause some of those epidermal cells to become cancerous. Hair could protect it, right? It's a covering. Jose Manzo, I'm not going to ask you again. I'm going to kick you out of the class if you do that. I've asked you a couple times now not to use Spanish. Now you're just wasting our time, and I'm starting to get upset. So Daphne says for natural selection. So Jose's saying to have women. So can you give me a little bit more info what you mean? Okay, thank you. Please don't do that again. Think about how we use our hair, guys. Don't we use it to look good? Right? We do. We style it, we color it, we blow dry it, we cut it, right? All that stuff. There's definitely an advantage when you have good looking hair, right? You can do things with it. So there are advantages just in terms of mating advantages, just in terms of look. That's important when we're talking about biology, when we're talking about anatomy. Being able to attract mates is important. And I would definitely say hair is a part of that. It plays a role in that. It also plays a role in protecting us from the sun, like Luis was saying. It provides protection from ultraviolet rays that would constantly be beating on the top of the head here. It also can provide a little bit of protection to the top of the head too. So we'll talk about that, Jose. So here's what hair looks like when it's coming out of the skin. Here's a diagram of it. It actually grows further down from the surface of the skin, and it has a layer of epidermis that follows this hair follicle all the way down. So you don't have to take any notes yet. And now, this is really important to when we get damage to our skin. It's really important that these hair follicles have all this extra epidermal tissue here where new cells can be created. Because sometimes when cuts are really severe or burns are real severe that affect the dermis down here, we use some of these cells next to the hair follicles to create new tissue to replace what's been lost or what's been damaged. Not only that, but right at the bottom here, we have what we call the hair papilla. And we'll talk about all these structures and we'll look at some hair and some images underneath the microscope. But this is where the hair actually grows. All of this structure is just like the same material we find in the stratum corneum. It's dead cells covered in keratin, that hard protein that makes it waterproof. So really, the only living part of your hair is, or the alive part of your hair, is way down deep in the bottom of this hair follicle here. And it grows from this point. It constantly pushes up, pushes up, pushes up, pushes up, pushes up, and just keeps pushing out. And it pushes out at a certain rate. There's these sebaceous glands that are found next to every hair follicle we have. And these sebaceous glands secrete oil or sebum to allow the hair follicle an easier way out of the skin. Without that oil, this hair follicle would tear all of these cells as it pushes its way out. This part of the hair follicle, or the hair, is known as the hair root. It's covered in these layers of epidermal cells, which are super important when we need extra cells in our skin. But right down here is where we have some blood vessels coming in, and the blood vessels are to provide oxygen and nourishment for that growing hair. Now, as we get older, some things happen in the body which shut this process off. And especially in men, sometimes, this doesn't necessarily happen in women, it can, but it doesn't necessarily happen. There's a particular hormone that causes this process to stop. And it happens in some individuals. We'll talk about that a little bit more when we talk about male pattern baldness. But I don't want to get too sidetracked here. This is skin tissue that's been sliced right where there's some hair follicles here. And you can see the hair follicles. You can see the shaft of hair that's growing. It hasn't quite left the skin here. Same thing here, the hair shaft hasn't quite left the skin. Here, the hair probably just something probably happened to it when this thing was sliced. At the very bottom, there's that hair papilla. At the very bottom here, here's that hair papilla. And you can't really see them, but there's some blood vessels that are probably really close to the very bottom of those shafts. So our first accessory structure that we're going to talk about is hair. So please write the words accessory structures and hair as the first one. The hair itself is dead, except for the very, very bottom of that hair shaft. It's made of keratinized epithelial cells. So it's almost like an extension of the epithelium that goes into the dermis. The two major parts of our hair that we're going to be learning about are the hair shaft and the hair root. The hair root is the part of the hair that's growing when the hair is in an active phase. Your hairs are in a cycle of growing and sleeping. Some of your hairs are in the growing phase. Those are the ones that are actually getting longer. Some of them are not. Not all of them are in a growing phase. When they're in a growing phase, the hair root is active, and then it connects to the hair shaft, and the shaft is what then leaves our skin. And that's what we actually see when we're looking at people's hair. The hair itself is produced in the bottom of the hair follicle. And so the hair that's growing is actually produced at the very bottom of the hair follicle. And it's right on the spot which we call the papilla. And remember, a papilla is like a little bump. Now the hair itself is made of 3 layers. There's the cuticle, which is the actual outer layer of the hair. That's the part that you see when you're actually looking at hair. You see the cuticle. So think of it as the outer layer of the hair. There's the cortex, which is the middle layer. Not quite the center of the hair, but the middle layer. So if you look here, this is a hair follicle. The hair itself is this part here. This is all still this is all epidermal cells here. This is connective tissue. So these cells are more like loose connective tissue. These are the epidermal cells. And then this is the hair. So we have the cuticle, which is the outer layer of the hair. We have the cortex, which is this middle layer here, the red cells. And then in the very center, we have what we call the medulla. And each layer of the hair has a different function. It's doing something different for the hair itself. Now, when we talk about hair, you can probably all agree that you've seen people that have different colors, right? And sometimes on your body, you'll have different hair that has different colors to it. The color has to do with that same pigment we find in the melanocytes in the epidermis layer of our skin. The pigment itself is made in the cortex of the hair. So the cuticle is translucent. Light goes through the outer layer of hair. It's this middle layer that actually has the coloring for our hair. It's the exact same pigment which gave color to our skin, which we call melanin. Now, whether you have really dark hair, whether you have maybe a lighter brown hair, whether you have blonde hair, or whether you don't have any color at all, that would be white hair, that all has to do with that same pigment, melanin, that we find in our skin. And that would make sense if you think about it, because hair is basically just another type of skin tissue. Oh, that's, yeah, we're gonna look at this on another slide, Mr. Lewin. Actually, the next one. So the most important things to know about hair is, one, that the hair shaft itself, the hair that we see, is dead. It's made of keratinized cells, just like the outer layer of our skin. It's very similar cells. The hair grows from the bottom of the follicle, and it pushes itself out of the skin. And luckily, there's oils that our dermis releases in that sebaceous gland that allow a lubricated journey for the hair shaft out of the skin. Now, that hair, like we talked about, has some important functions for us. It protects us from the sun. It also helps us with mating. It also helps guide where sweat moves on our body. Think about your eyebrows. Let's not just talk about the top of our head. Think about your eyebrows. Why do you think we have eyebrows? What do you think the eyebrows do? Not the eyelashes, the eyebrows I'm talking about. See you later, Eric. Mr. Eric. Well, what's the purpose of eyebrows is what I'm asking. So for good looks, possibly. There could be a mating advantage to it. What else? I imagine they could, yeah, if they wanted to. Have you guys ever done something? So Daphne says protect our eyes. Protect our eyes from what? Dust. What's polvo? Okay, let's just do English then. Braulio says from sweat. Ooh, interesting. So we say our eyebrows protect us from dust, which is possible if there's dust coming this way, right? Maybe much more so our eyelashes are more important for protecting from dust, but the eyebrows could do that too. But think about sweat. So when you sweat, it could run down, and if you didn't have eyebrows, that sweat could go right into your eyes. And in fact, we find that when we sweat, your eyebrows actually act as a barrier from the sweat getting into your eyes. And so not only does our hair provide us protection from the sun, some hairs in our body provide like a cushion for us. Some hairs in our body provide protection from dust, from certain particles, but our hair also has a function with our sweat too, directing the sweat. Even the hair on our arms, it helps us move the sweat away from the skin because the sweat will beat up on the hairs themselves. So hair has a lot of functions. I'm sure you can agree. Now the hair color itself, why do you think we need hair color? What do you think color helps us with? So if we're looking good, possibly, yeah. Make us unique, possibly. Protect us from the sun, possibly. Remember how melanin protects us almost like sunblock? That's why we have it in our skin. Well, it's probably the same reason why we have it in our hair. It provides another layer of protection from ultraviolet light. It can take some of that ultraviolet light and reflect it off. So it adds as more protection than just the hair itself. If we just had this hair follicle, which has the hair growing inside, and we just had translucent hair growing out, which basically would look white. When hair doesn't have any color, it looks white. We wouldn't have as much protection from the sun as we do if it was a little bit darker. And so what these cells right here do, the cortex cells, is they produce melanin to give coloring to our hair. Now, to answer your question a little bit earlier, Jose Monzo, sometimes people lose the ability to create color in their hair. That usually happens to all of us at some point in our aging. As we age, the cells that have to replicate themselves over and over again start accumulating errors. This is why we age. When we make new cells, those new cells we're creating are a little bit broken, with lack of a better term. And so as we accumulate those errors, and you're accumulating in your DNA, we start to lose the functions of certain cells. And if you talk to your grandparents, you can ask them, I'm sure they've lost some functions in their body. They probably don't even like to think about it. But as you get older, your body can't do the same thing it could do when you were younger. It's the same thing with your hair follicles. As you get older, your hair follicles lose the ability to produce melanin. And eventually they may even lose the ability to produce hair at all. And so as we get older, the melanin stops in these hair follicles, in the cortex of the hair, and they look white. Same thing can happen to some people that are under a lot of trauma. Sometimes we see people who have been in a really traumatic experience or have real bad anxiety, usually a very severe incidence of anxiety, lose the ability to create color in their hair. And they may even have white hair for the rest of their life. Or maybe they have white hair until newer hair grows in its place. That can happen too. But it just, a protein, melanin, is not being created in these hair shafts, particularly in the cortex right here. So this is what hair looks like under a microscope. Jose can stretch your hair all the time, be a sign of cancer. I've never heard of that before. So you can see the outer layer of the skin has this squamous appearance to it, very similar to the outer layer of our skin. squamous, these are all the dead keratinized cells right next to each other, squished. So we say squamous, remember, when we're talking about squished looking cells. You can actually see through the cortex, excuse me, the cuticle, and you can see the cortex. That's this brown color that gives the color to the hair. You can't see the medulla because the medulla is in the very center of the hair. But the outer layer is actually translucent. That's actually what gives a little bit of the shine or the sheen to hair. Why is it? What's your question, Fernando? Oh, somebody just wanted to show you what hair looks like under a dissecting microscope. So it's just a microscope that magnifies something you put on a tray. And to see maybe the see-throughness of the hair a little bit better, I think they probably put it in a knot. Do you see how you can almost see through the hair a little bit? Kind of gives it a good way to see how kind of translucent hair can be. You can see the image, the part of the hair crossing over it around there. It's probably why they put it on. I actually don't know why. Now, if you were to take a light microscope and look really close to the cuticle, this is what it would look like. Here's all of your squamous, squished cells. They're packed close together around that hair shaft, and they're all dead. They're all covered in that protein keratin, and this is what they actually appear like when you look really up close. So now, we talked about the different colors hair can have, right? You can have real dark hair like this. You can have lighter color hairs. You can have red hairs. You can have more lighter brown, which we call blonde hairs, or you can have no color to your hair, and that's white. Oh, let me go back to this image here. So the reason this image was here, I forgot, it's because you guys have all heard of split ends. Especially if you have long hair, the ends of the hair can like break apart. We call that split ends. And usually there's nothing you can do for that. Usually you just go in have your hair cut and they cut the split ends off. What's actually happening when you have split ends is the cuticle itself has fallen off of the hair shaft. And all that's left is the cortex and the medulla. And when that happens, sometimes the hair starts to break apart because the cuticle is actually holding it in its shaft shape, actually more like that. And the reason that happens is the hairs get dry, the hairs get old, and these cells are constantly falling off, just like the cells on our skin are constantly falling off. So if you let the hair grow long enough, and if you don't take care of it, these cuticle cells can just fall right off. And when that happens, the hair breaks apart and you have a split end. There's really no way to heal that. At that point, you just cut the hair off. This is another thing that happens to people's hair. You start to get receding hairlines. I have a pretty receding, my hair is pretty bad this morning, so I won't take it off, but I have a receding hairline. I started losing my hair when I was like 19, I think. And it was slow, you know, my hairline started to move back a little bit more. And then you sometimes start to lose hair in the back. We call that a bald spot. And then it's just over the years, keep losing more and more hair. This usually only happens to men. And so we call this male pattern baldness. And we call it male pattern baldness because there's a certain pattern it follows. Usually starts at the front of the head, the hairline starts to recede a little bit. The hair here starts to basically die. The follicles stop producing hair. it also sometimes starts in the back of the head, which creates the bald spot. And sometimes it stops right there for some guys. Sometimes it will continue all the way until only the sides remain. And the reason this usually only happens to men is because there's a hormone that men have much more of than women. And it's a hormone that's only produced because men need this hormone. It's called testosterone. Now, testosterone is literally what changes the female body into a male body. So when we were all in our mother's womb, we all started out as female looking. And then as we developed, if we were men, if we had the right DNA, we slowly got a little bit of testosterone. And that testosterone turned that female looking embryo into a male looking embryo. If you're female, you just developed as you started out. Female looking, you keep developing into female. Testosterone gets broken down into another hormone called dihydrotestosterone when the body's trying to get rid of it. That dihydrotestosterone likes to grab onto hair follicles. And when it grabs onto hair follicles, it tells the hair follicle to start dying. Now, why it does this, we still don't know why, but we know that it happens. Now, women have much less testosterone and much less dihydrotestosterone in their body because their bodies don't need those hormones as much as men. And so women never really see balding like men do. If for some reason you were to add that hormone to a female body, then females could start getting male pattern baldness if they were prone to it. And this is the key. Not everybody is prone to the hair follicles dying as a result of dihydrotestosterone. DHT, we call it. It's all based on genetics. So if your father lost his hair, there's a chance that you will probably lose your hair. If your mother's father, so your grandfather from your mother's side, lost their hair, you have a really good chance that you're going to be losing your hair when you get to a certain age. If everybody in your family has a full head of hair and you're a guy, then you probably won't have male pattern baldness. It all has to do with your DNA. So you'd have to look at your family, look at your parents, your grandparents, all the males, and see what kind of male hair they have. And if they end up having balding, then there's probably a good chance that you'll have it too. Let's just talk about the hair growth cycle and then we'll finish for today. So the hair growth cycle. Hair grows about every 2 to 5 years, your hair goes through a complete hair growth cycle. So what that basically means is the hair on the top of your head, the hair on your body will grow for about 2 to 5 years, and then new hair will start to come in to replace it. And then that hair usually falls off, and it's all happening at the same time. So it's like you don't just lose all your hair after 5 years, and then all of a sudden in 5 years get a whole new head of hair or a whole new body of hair. It's all happening at the same time. Some hairs are in a growing phase, some hairs are not. And so you never really notice when the cycles end and when they begin. But we know that hair follicles can rest. After 2 to 5 years of growing, they start to rest. That old hair falls out, and then a new hair will start to grow right next to it, or in another hair follicle right by where that hair was growing for 2 to 5 years. And I think we'll stop right there for today because I want to give you guys some time to work. So please get all of this information from this slide, and we'll actually pick up right where we left off, talking about goosebumps when we come back. So the hair grows for about 2 to 5 years, and then it goes into a rest phase for about 2 to 5 years. Then it grows for 2 to 5 years, and it's different for different people. So some people's hair grows for a couple years, then goes into a rest for a couple years. Some people's grows a little bit longer, and then goes for a rest a little bit longer. Just depends, again, on your parents, your genetics, and where you came from. But the more important thing to know is just that hairs grow in a cycle. So some hairs will be growing, some hairs don't. And actually the reason we have male pattern baldness is because that DHT hormone that comes from testosterone tells the hair follicles to rest. And we don't really know what the purpose of that is, but we know that they put the hair follicles into a rest phase, and then eventually those hair follicles towards the front and maybe in the back of the head, they rest, and the body then attacks them and kills them. And again, there's a lot to it. We don't really know why this takes place, but it happens. All right, so